Good evening, everyone. This is the live interactive session for Simulink Design Optimization, and I'm Vishaka Srinivasan, and I'll be your moderator. Along with me, I have my friend Roshni, who will be my co-moderator, and the host, Edward. Roshni?
Hello everyone, I'm Roshni and I'll be co-moderating this event along with Vishaka. And I have a few questions to ask Edward and I'm looking forward for his answers.
Hello, I'm Edward from MATLAB Helper, and I am hosting the webinar on Simulink Design Optimization. So if you have any query, please let me know.
Okay, so before we start, I'd like to mention that we are giving giveaways for the top 5 comments and the decision. So feel free to uh, ask whatever your queries are, as it will help you get free goodies. So to begin with, Edward, which is easier, optimization using MATLAB or optimization using Simulink?
Well, I think this depends basically in the people who is interested to do uh, this optimization. Uh, I think this depends on their skills. Uh, I think maybe it's a little easier using Simulink instead of MATLAB because if you want to do the optimization in MATLAB, you will need to know about some functions or codes which are not commonly easy to understand.
Fair enough.
What criteria could be used to select some parameters to be estimated?
Okay, I think this criteria will depend always on your model and how you feel confident for choosing this parameter. Let me give you an example. If you are modeling a spring mass system, it's probably you be interested in estimate the friction value uh, instead of choosing the mass value because it's probably at the end uh, that you know the mass value but not the friction one. Otherwise, we can consider other examples, like for example, in a DC motor, uh, where maybe you could choose estimate its inductance instead of the resistor value, for example. Of course, these examples are or could be very simple, but there will be other systems which not, like for example, some models for modeling uh, the behavior of the glucose levels for patients with diabetes. For example, there is one model related to this, which includes a set of 16 differential equations, linear and nonlinear. So maybe you can imagine that this kind of model are more or have more complexity, and the parameters, the number of parameters to be estimated could be bigger.
Okay, so the next question is, where do I find the Simulink Design Optimization?
Um, you can find the Simulink Design Optimization first going directly to MathWork page. You can download from here. Or second, if you have started MATLAB environment, you can go to the add-ons menu and you can type Simulink Design Optimization and you can install it from this.
Okay. So I have seen in the parameter estimation app, there is an option called sensitivity analysis. So I just want to know how it works.
Sensitive analysis is a very useful tool uh, which can be used in, let's say, two steps. The first step or situation is before the estimation. Uh, if so, before estimation, it is useful to identify which parameters uh, of your model have the most influence in order to choose only these parameters to be estimated. Uh, Additionally, this tool help you to uh, assign or define an initial value for these parameters that you want to estimate. And second, after the estimation, you can use this tool to test how robust is the cost function to small changes in the values of the optimized parameters.
Okay, so I have a question which is sort of near to what you've just answered, and it's what is the difference between validation data and estimating data?
Okay. Uh, Estimation data and validation data, let's say at the end, are data. The difference is estimation data is for when you want to estimate the parameter. So you take this data and you, uh, let's say, um, selected this data and the Simulink Design Optimization toolbox ensures to estimate these parameters with
Mm-hmm.
this data. And validation data is finally to compare if the previous estimated data fit with both simulation data and other real data.
Okay, so validation data is to check if the uh, estimated data is correct or not, right?
Yes.
So what other optimization methods could be used to estimate the parameters?
Uh, okay, you can find at least four optimization methods. The first is nonlinear least squares. The second is gradient descent. And also you can find a pattern and simplex search. Uh, Maybe you could be interested to know that there are some family of numerical optimization methods, like in the case of pattern search method, this doesn't require a gradient. So this this method could be used instead of gradient descent for the case where the performance of the gradient descent method won't be the best.
Okay.
So we have this question from the YouTube live from Subrat, and he's asking where do we find Simulink-based optimization techniques? Is there any application in real life too?
Oh, yes, since we are also working with model, uh, it's probably you will face this kind of problems where you collect the real data and then you go to Simulink and you simulate the model, and it's probably that both behavior
Hmm.
from the real and simulated system uh, is not the same. So for real examples, you can find uh, the designing of some filters. Uh, as I mentioned previously, DC motor, spring mass system, systems, other systems, which includes controlling temperature, um, other biological systems like which models, for example, glucose levels in patients and other kinds of uh, um, situations.
Okay, so I hope Subrat your doubts are clear.
We have one more question from the YouTube live session. So this is from Nitin. He's asking, how is tuning model parameters initialized in the Simulink?
Um, I'm sorry, could you repeat the question, please?
Yes. How is tuning model parameters initialized in the Simulink?
You mean how to define initial condition to the parameters to be
Yes, yes,
estimated?
yes.
Okay, okay. Well, maybe you have different ways to do it, since you can also define by your own. Um, for example, if you know the model, you know, or you are familiarized with these parameters, and in some way, you know what range of values are possible to be this parameter. You can define these initial values uh, by your own. But if you want, you can choose also sensitive tool. This tool also allow you to specify initial condition. Uh, I think that this depends on you.
Okay. So the next question we have from the YouTube live is from Mayuri, and she's asking, how can we estimate parameters like magnitude and phase? What kind of data should we use?
Uh, okay, regarding that in Simulink Design Optimization, you can import some different types of data. For that case, uh, you could use complex data uh, for this uh, for this requirement. Uh, about the first question, I'm really not sure in this moment. Maybe I can answer you later.
All right.
Okay. So next question is like having a low cost function value at the end of the estimation process. What does it mean? Does it mean that the parameter was computed correctly?
Okay. Mm, for that case, the answer I think is not really, and this is because even you get a low cost function value at the end of the estimation, it's probably that with these values you have overfitted the model, what means that these computed values work only or will work only with the data used for the estimation, estimation data, but not for other Nyasuri data.
Okay, so the next question is the PID block allows you to auto-tune control parameters, right? So then why should I use response optimization app?
Okay, because response optimizer app allow you to use more requirements than PID block allow you. In PID block, you can choose uh, if if I am not wrong. For example, if you want a faster or slower response, and how robust. the response can be after the auto-tuning process. While using response optimizer, you can specify other requirements. You can specify time domain requirements, frequency domain requirements, and actually you can define your own, let's say, rules or specifications.
Okay.
Okay. Now, how can we prevent overfitting?
To prevent overfitting, you can specify uh, some kinds of constraints in the parameters that you want to estimate. For the example, when we was talking about the spring mass system, uh, in the case you have choose friction value to be estimated, it's probably you know that this value can't be negative, so you can go to the parameter estimation app, you select the constraints, and maybe you could specify uh, friction value, minimum friction value as 0. Um, for that case, and also a other way to prevent overfitting is specify a a range of values for some parameter.
Okay, so we have a question again from the live session. It's from Subrat, and he's asking, can these optimization techniques be used for 3D surface analysis?
The question is if this toolbox can be used for 3D analysis.
Yes, 3D surface analysis.
Okay. Well, actually, I never have asked me this question. Uh, Really, I'm not sure. Maybe I should think more about this question and maybe later try to answer.
Okay.
Okay. So in the webinar, you have used a response optimizer app to find some best controller values using the PID blocks. So is it possible to use these apps for other techniques also?
Sure. Since you are using Simulink Design Optimization for estimating values, you can imagine that these values are the values for some controllers. Uh, let's say uh, if you want to uh, tune a PID controller, so you know that you have to find values for a proportional constant, derivative constant, and uh, the constant related to the integrator. So having into account this, uh, the answer is sure. You can design other controller techniques, like for example, for control system in state space representation. You can design poles assignments controller, which is basically a set of gains of constants. So you can easily do or estimate these constants using Simulink Design Optimization. Also, you can try other or more complex techniques like nonlinear controllers, for example, backstepping, sliding mode control, and feedback linearization approach.
Okay. So the next question here is what to do if the response becomes unstable and does not recover during the estimation process?
Okay. For that case, you should first sorry, choose a lower and upper bounds for the parameters, because in this kind of situation, the response of the system becomes unstable, because some values, some parameter values get bigger and bigger during each step of the estimation. Um, so if you choose upper and lower bounds, it's probably you could resolve these kinds of issues. And also you could try to change the optimization method.
Roshni, you're mute.
Yeah, we have a question from the YouTube live session. So it is from Nitin again. So he's asking, how can we evaluate the cost function at each set of parameter values?
Um, well, uh, as you know, you can first do the estimation uh, in Simulink or in MATLAB. So if you are working in Simulink, uh, the same toolbox uh, during the estimation process will be showing you the value of cost function. So in this way, you can see how the function cost function values are shown, and see how these values are decreasing uh, for the case the estimation be working in the expected way.
Okay.
Okay, so the next question here is from Manoj, and he's asking what are the applications of the toolbox. I guess we've already mentioned parts of it. He's asking what are the applications of the toolbox.
Oh, okay. Mm, well, I was mentioned some applications previously, but
Mm-hmm.
that's okay. Uh, from my experience, the most important application, or the main application that I have given to this toolbox uh, have been for control systems, uh, for estimation parameters in both for model and controllers as well. Uh, and then you could imagine that there are a lot of models. Uh,
Mm.
I think this depends, or in the general idea, the applications will be applied to models and controllers. This would be my answer.
Okay.
So usually some toolboxes come with some Simulink blocks that could help you. So which blocks come with Simulink design optimization?
Okay, yes. You can find three important blocks. Are not the unique, but I think they are the most important. You can find check custom bounds, check step response characteristics block, and check against the reference block. Uh, these blocks, each one of these blocks allow you specify some requirements for your response. And, and also, maybe you should know that if you want to specify the requirements for a system, you can do it from these blocks, or you can do it directly this using the app. The is the same at the end.
Okay, so the next question is from the YouTube live, and Mayuri is asking, can you edit design requirements graphically in SDO?
Okay. For that, I know that you can do the same things for these kind of toolboxes uh, using different approaches. As I mentioned it previously, you can use this toolbox from MATLAB or Simulink. Uh, Also, you can specify requirements inside the app or using the blocks that I mentioned previously again, but I'm not sure if graphically you can do this. In my case, I never have done this, so I'm not sure if it's possible.
Mm.
Okay.
So what happens with the estimated parameters if you do estimating process without removing the noise in the real measured data?
Okay. Um, for that case, I think these kinds of things depends mostly on the data. Sometimes the estimation process can fail. That means the parameter have been estimated with low accuracy, or if your response is very noisy and you don't pre-process the data, Simulink Design Optimization will, let's say, assume these noisy components of the signals uh, are part of the real data and assume this noisy is not noise. I'm not sure if what I say have sense for you, but this is the idea. So since pre-processing data will not take you a long time, not in most of cases, uh, I would recommend you to do this.
Okay. So it
Okay.
is better to pre-process the data since it takes
Yes.
less time. Okay.
So adding on, how many ways of pre-processing are there?
Okay. And there are actually different ways to do the processing data. You can, for example, filter the data. In the filters, you can choose the order of the filter uh, and the cut-off frequency uh, as well. You can extract data. For example, if you have data between a specific range of time, let's say 0 to 10 seconds, you can extract the data between 0 and 0. Sorry, 0 and 5 seconds, depending what you want. You can scale the data. You can remove the offset, and also you can resample the data.
Okay.
Okay. So what frequency domain requirements can you request in Response Optimizer app?
Okay. You can specify damping ratio, natural frequency, uh, gain and phase margin, uh, and finally, closed loop peak gain. They are the most common requirements that you can choose.
Okay.
So here's a question from the YouTube live. It's from MATLAB engineer, and they're asking, can you talk about the ANN controller?
Um, well, I didn't understand you exactly the question.
They're asking if you can talk about the ANN controller.
Um, the EAN is, sorry,
ANN. A for Apple, N for net,
okay.
ANN.
Um, I would think, sorry, I think I should, I'm not sure really about how to answer this question. Sorry. Uh, I'll take some minutes to think about this question.
Okay.
Mm.
Hmm. ANN as an artificial neural network.
Oh, okay. Uh, well, from my experience, I have not worked with these kinds of controllers. So the information that I can give you maybe won't be useful for you in that case.
Hmm. Okay.
So, what kind of data can you import to be used for estimating parameters?
Okay. You can import real and complex data. You can, for real data, you can import time series data from time series object. Um, you can use or import variables that you have created in your workspace. Also, you can import data from different files like MATLAB files and Excel files. So I think they are the most important kinds of data that you can use.
Okay, so here I have one question, and is it possible to speed up the parameter estimation process?
Yes, you can speed up this process using parallel computing toolbox. So remember, you have to install this because for using Simulink Design Optimization, there are some, let's say, mandatory toolbox that you have to install. So since parallel computing is not mandatory to use this toolbox, uh, maybe you go in you think you can speed up the estimation process, but you you find later that you have not installed this toolbox. So please install it.
Okay.
I think we are done with the questions. Am I right, Dakar?
Yes, yes. So for now, we'll wait for like a couple of minutes till to see if there are other people who want to ask more queries. Till then, I'd like to guide you through the certification process. Um, just a minute. I'll share my screen. So can you see my screen?
Yes, yes.
Hmm.
Yes.
So this is there in our website, and here, like it says, you have to score about 60% plus to get the certification. But obviously, you can apply for this. You can attempt this quiz as many times as you want. Um, so yeah, here you fill in the quiz and like attempt the quiz here. I'm filling in random options here. Now, here like to bring to your notice that the 5 best comments in this webinar will be getting special benefits as mentioned earlier. And like I said, but the only thing here is that you'll have to attempt the certification. Only then will you be eligible for the benefit. And you'll have to attempt the quiz within 24 hours. All right. I guess I'll stop sharing my screen. I guess there aren't other comments. Um, okay, so maybe Edward, we'll finalize on the top five comments.
Yes. The first is Kumar.
Subrat,
Yes.
Subrat Kumar Panda, right?
Yes. Sorry if I didn't pronounce well.
That's okay.
Uh, the second is Abhishek.
All right.
Um, the third is Mayuri.
Hmm.
The next is Nitin.
All right.
And finally, uh, mm,
We have two people here. I guess MATLAB engineer and Manoj.
yes, MATLAB engineering.
Okay. So the winners, please attempt the quiz so that you can avail the giveaways. Also, I'd like to highlight the next week's webinar, which is 2D mapping, 2D mapping using Arduino and ThinkSpeak, and um, and yeah. So the thing is, you learn to use MATLAB support package for Arduino and ultrasonic sensor, dealing specifically with autonomous robots along with servo motor to create a 2D map of the environment. I hope you'll tune in for the next event. Until then, thank you. Bye bye.